First, draw a circle with diameter 1. Next, draw a square around it so the circle is perfectly inscribed in the square. Notice that this square has perimeter 4. If you add up all the lengths of its sides, each side is length 1, you get 4. Now remove the corners of the square and connect the shape to the circle in this way. Notice by symmetry, the perimeter of this shape has not changed. It's still 4. If we keep removing the corners in this fashion, the perimeter of the shape around the circle is still 4. Repeat this out to infinity, and we'll see that this process maps the shape onto the circumference of the circle. What is the circumference of a circle? We know its diameter times pi. In this case, 1 times pi is pi. That's the circumference of this circle. But the perimeter of this shape approached that circumference, and its length was 4. So pi is 4. Unless this is the conclusion that you want to make, and I don't think that it is, we need to figure out what's going wrong with this. Fact is, this illustration doesn't prove anything. It just sort of feels right. And maybe not even that. To mathematically justify this, let's look at a similar version of the problem. Draw a unit square and its diagonal. Let's use a similar process to try to figure out what the length of this diagonal is. If we follow the perimeter from one end to the other, we see that this path length is 2. Cut out the upper corner of this region and travel the perimeter again, we'll see that this again is path length 2. Repeat over and over out to infinity, the length of the path is still 2. And our path approaches the path of the diagonal. So should we conclude that the length of this diagonal is 2? And the answer is, of course not. The problem with this is that just because one path approaches another, it doesn't mean that the length of the path approaches the length of the other. How can we mathematically show this? We can say that the staircase path approaches the diagonal by looking at the area between them. If this area shrinks to 0, we'll say that the staircase path approaches the diagonal path. Let n be the number of iterations in this process. So when n equals 1, we have one step making a triangle with base 1 and height 1. When n equals 2, we'll have 2 steps with base 1/2 and height 1/2. So for a general n times 1/2 times 1 over n times 1 over n, we have n triangles, each with area 1/2 base times height. In other words, the area of the nth iteration of our process is 1 over 2n. And we can see this area shrink to 0 by taking the limit out to infinity. Thus, we conclude that the staircase path does indeed approach the diagonal path. However, if we do a similar process for the lengths of these paths, starting at n equals 1, the staircase as a path length is 1 plus 1 is 2. At n equals 2, the staircase has path length 1/2 plus 1/2 times 2 is 2. Our path length is 2 regardless of what the iteration number is, and if we take the limit out to infinity, the limit of a constant is a constant, we still get 2. But we know the true length of this diagonal by the Pythagorean theorem. Just say 1 squared plus 1 squared equals the diagonal's length squared. The diagonal's length is square root of 2, which is different from the path length of our staircase. One path approaching another does not mean that the path lengths are equal. And this logic exposes the fallacy that pi equals 4. I think it's great that you love learning through video, but the best way to learn is by doing it yourself. And you can do just that with the sponsor of today's video, Brilliant. If you don't already know, Brilliant is a fun and interactive way to learn real problem-solving skills and deeply understand math and science. There's courses for all ability and knowledge levels, so you'll definitely find something that interests you. Personally, I've really been enjoying their logic course. I feel like it's helping to keep me sharp, and there's some really fun puzzles in there. You can get started for free with Brilliant's interactive lessons by clicking the link in the description. Plus, the first 200 people to click will also get 20% off an annual membership. And if you thought this paradox was fun, you'll especially like this one. Click the video on the screen to check it out. I'll see you in that one.